Welcome, Math 20-3 students. Today we're going to look at surface area of pyramids, cylinders, spheres, and cones, which is topic 3.2 in your workbook. And I'm going to go through some examples of how you can solve some of these surface areas from the wire diagrams here. These ones are not in your workbook, but they're similar to the ones you'd have to tackle. Alrighty, so let's dive in to calculate the surface area of any of these shapes. Here we've got a pyramid, which assumedly has a square base. Why do I assume that? Is because the dimensions on the bottom are the same, so 37 and 37, so the base is going to be a square. So now, what we're going to do first, probably the easier one to do, is work out the area of the base. When checking your formula sheet, although you probably don't technically have one handy, the area of a square is going to be length times width. In our case, the values are 37 and 37. So length times width, 37 times 37. And we also have inch times inch. Don't know how to do that, so I bring my calculator over. Oh, it's kind of small. Let's make it a little bit bigger so you can see that. Alright, turn that thing on. And 37 times 37. 1369 is going to be that area of this base. This is this space right here. Alright, so 1369, and we have to deal with these inch times inch, which is going to be inch squared. Okay, so far we've got all this. Now, to calculate the rest of this, we have to view this as a net diagram. So if we can imagine this lovely little pyramid unfolding, what we would see is something like this. It just flowers out with 4 equal triangles. If you can imagine that thing flattening out like a takeout box. Okay, we've taken care of this. What we have is basically 4 identical triangles that are going to be exactly the same. I'm just going to quickly draw a triangle that will represent one of them. It's not perfect, but it'll do. Now, in the triangle we have this 44 inches, which is very important to understand that the line is the 44-inch dimension is this dimension in the triangle when it's laid flat, aka this dimension, which corresponds nicely to the height of the triangle laid flat, so 44 inches. Now we look at the triangle here, which corresponds to this, which is basically this value here. This is 37 inches, which is the base of the triangle. Alright, so let's now calculate, I'll just change colors for the sake of argument and of interest, the area of a triangle. Area of a triangle, and formulaically it looks like base times height divided by 2. The base is 37, so 37 times the height of 44, and then divide that by 2. I'll bring the calculator up for that. Here we go, clear everything off. It's going to be 37 times 44, hit enter, divide by 2. So this gives us the area of one of those triangles. Back that up. Okay, the area of a triangle for one of them is going to be 814. And we still have inch times inch, so inch squared. It's important to note that not only do we have one triangle, we've got 1, 2, 3, 4 of them. So what we're going to do with that is we're going to take this area of the one of them, and then we're going, whoops, that's an ugly color to have on the big screen, times that by 4 to account for the fact we have 4 areas on the outside. And so we can simply do that times 4, giving us the area of all the triangles. 3. Whoa, bad. That's technology for you. 3. Whoa, bad. Wonder what's going on here. Let's try that again. 3, 2, 5, 6. I guess it likes a nice stable surface. And we still have inch squared. Now, essentially, we figured out for area this part and all area for triangles. Now, for the total surface area, we're going to take this total right here. Let's actually change that color so it's something a little bit more obvious. Okay, we're going to do and make it a little bit more highlighted that way. So here's the areas of our triangles. Here's the area of the square in the bottom. What we're going to need to do in the end is we're going to need to add them together. So surface area is equal to the area of the square plus the area of the triangles. Alright, thin line, or medium-sized line, black again, which is going to be equal to 1369 plus the 3256. And let's just, oh, it's already up on the screen, so I'll take the 3256. I'm going to add 1369. And our total area for this thing is equal to 4,625 inches squared. That's our surface area. Alright, that's problem 1. I'm going to use my zoom tool here and realize we got more on this page. So we're going from a pyramid. And now we have this thing called a cylinder. Let's just zoom in on that. Whoa. Lovely. Let's just actually, it's a little too big. Nice. Alright, so we have a cylinder. We're going to need to check the formula for a cylinder. Well, basically what we have is we have 2 major parts. We've got, let me just grab the highlighter. If you can imagine, in fact, actually, let's change this to this. If you can imagine, we've got a top part and a bottom part. Ooh, I can even change the color of this thing. So I can go a bottom and a top. Lovely. And as such, this is going to be, when we see it totally, it's going to be a circle. So in fact, we have a circle with a diameter of 76 centimeters. You can see that, hopefully. All right. We're going to need to calculate the area of one of them, but we're going to have to double that up. So we have top and bottom times 2. Area of a circle is equal to pi. Let's undo that and make that a little thicker for ourselves, just to see it a little bit better. Area of a circle is pi r squared. Now we have the diameter, so we need to cut that in half. Just in case we forgot how to do that, well, 76 divided by 2. So the radius is 38. So from here to here is 38. And the unit is centimeters. So the area of the circle on the bottom is going to be pi times 38. Now because it's squared, one way to do it is 38 times 38. It's also sufficient to use 3.14 for pi if you really want to, but there is a pi button here just by pressing second and that exponent button. Totally fine, because if you don't have this calculator, just to do 3.14 times 38 times 38. Alright, clear my screen. So I'm actually going to use the button. So pi times 38. 8 times 38. And so the area of one of these circles is going to be 36.45 and all that kind of stuff. Doesn't really matter precision. Now, because that's only one of them, and we have a top and a bottom, we're going to double that up. So I'm going to say times 2. So the area of our circles is going to be equal to 9072.9. So roughly 9073. And because we had this 38 times 38, which is a centimeter times a centimeter, we have 7 centimeters squared. All right, that takes care of this part. Now, what happens is when we take the other component, that we have this 36, what's that doing there? Well, that's the side. And that side is going to make this nice, a little bit prettier. That side is going to basically roll straight out as one of these. Not perfect, but hopefully recognize that shape. That's going to be a lovely little rectangle. And we already have that this is 36 centimeters here. Okay. Now our problem is our area of a rectangle, okay, length times width. Well, we've already got one of those, so if we call that the width, that'd be 36. Great. Now the length of it is a bit more problematic because it's not 76. It keeps stretching out and rolling out. It, in fact, is the circle being rolled out. So the length is equivocal to the circumference of the circle, which is pi times the diameter length. Okay, that's the length there. So if I was to figure out the area of the side, let's just break this off here a bit, of this rectangle, it's going to be length times width. Now the length is the circumference of this circle right over here, which is pi times diameter. So pi times diameter times the width. So it's going to be pi. The diameter of the circle was already provided as 76. The width being 36. Now, again, these two dimensions are centimeters times centimeters. That's how we're going to get our square unit from those two numbers right there. I'm going to now use the calculator to figure out what this number is. Again, I'm going to use the pi button. If you use 3.14, you're going to be perfectly fine. So if I did 3.14 times 76 times 36, I'm going to get 8. Whoa, that's ugly. How did that happen? 8, 5, 9, 1, and I have that 0.04. It's kind of irrelevant. And I have centimeters squared. So this is the whole area of this rectangle here. And as per usual, what we're going to need to do is take this one and this one, which gives us the green and the rectangle, and we have to add them up. So back to my line there. It's a little thick. That's okay. I'll put the medium line on. So our surface area is going to be the area of the circle plus the area of the rectangle, which can be represented as that little shape there. So we're going to have 9073 plus 8591. And of course, we have centimeters plus centimeters squared. It's going to maintain our unit of centimeters squared first. And we'll just add these numbers up now. I'll even clear and just use the rounded numbers. It's perfectly acceptable. 9073 plus 8591. And it gives us approximately 17664 centimeters squared is the area of this cylinder. All right, moving along. I've got a lovely little sphere. And we're asked to figure out the surface area of this shape. Thankfully, all spheres and balls and circles have one singular dimension. They're all made up of one distance from the core of the center of it to the outside edge. Namely, there's only one dimension, the radius. Right there. Okay. If you check your formula book, formula sheet, you'll see that the surface area of a sphere is 4 pi r squared, which means 4 times pi times the radius times the radius, if you need to do it step by step in your calculator. So it's going to be 4 times 3.14. The radius is 12 and 12. Now, because these dimensions are actual dimensions and not just simply scalar multipliers, they have centimeters times centimeters, giving us, in the end, a centimeter square issue. Now I'm going to go and type these in on the calculator over here. 4 times 3.14, good, type that out, times 12 times 12. And so we have the surface area of a sphere for this problem is approximately 1808.64 centimeters squared. One easy, simple little shape. And moving along to the last one. Clear that off. All right, so we've moved on to the shape of a cone. We have to figure out the surface area of a cone, which is comprised of two parts. Okay, the base area you can see. Let's just play with colors because we can. All right, if hopefully you can see that, and the base is one of these, a circle. Lovely. And the surface area, or rather the area itself, is just simply going to be the area of a circle, which is pi r squared. And we have to add this cone thing. Now, if you didn't know what's going to happen with a cone, let's see if I can do this right. A cone is going to be made up of a bit of a triangular shape. Ready? But it's not a perfect triangle. It's actually going to be a segment of one. Can I do it? Can I do it? Can I do it? Oh, well, we'll call it I did. This shape, which, if I was to continue, let's just do this. All right. Is actually a part of a bigger circle, okay, which you don't actually see. So somehow the formula, the area of this cone area is actually related to that of a circle, okay? All right, so you will notice that when we check your formula sheet, this area is pi r s, where s is the slant height, which is not the same as the vertical height. Okay? The slant height is actually comprised of right here. What we have in our diagram is this hard one. This is where the s is. It's on a slant. However, we're given a vertical height. And we're going to need to do a bit more work to figure out what that slant height is. We already have the radius, which is given as 10. Okay, that's a given value already. The radius is 10, which is the same for here and here. But now we've got to calculate the s. Now the s is also the same value that's right here. Okay, slant. And I'm going to just draw that triangle out separately. again. Whoops. So we have 10. And we have the vertical height of this triangle happens to be a whopping 29.5. And these are both centimeters. And we need to figure out this value right here along the diagonal. Well, if you recognize the very fact that we've got this shape right here, says this is a right triangle. We have two sides of a right triangle trying to figure out the third. Pause dramatically. All right, and let's recall that if I was to zoom out, whoa, way big, way too zoomed out. I don't know what happened there. It just went all over the place. Okay, zooming out here, remember what we essentially have is a square and a square. And we're trying to figure out the other square that makes this up. Look familiar? Yeah, Pythagorean theorem. So we're going to figure out the area of this square and the area of this square, add them together, and they're supposed to add up to that one. Okay? So, we're going to use a thick line. Hopefully that's thick enough on the screen. I don't know if it's going to be any thinner. The area of this square, area of the square, square, is going to be length times width, which our case is 29.5 times 29.5. So the area of this square is 29.5. I can use the square button, which there is here, but I can just simply go times 29.5. All right, that's 870.25. That's the area of this space right here. Now the area of this square, again, is going to be a square of length times width, which is equal to 10 by 10, which hopefully you recognize is 100. Okay, if we were to add these two together, so we're going to take 870 plus 0.25 plus 100, which is, hopefully you can do mentally, if not, plus 100. That tells us the area of this big old square here, this area of this square here, is going to be 970. So the area of the big square is going to be 970.25. And it's centimeters squared. That's the whole space this takes up. Well, conveniently, this is a perfect square. So that means the side lengths are exactly equal to each other. And to figure out the side length, we just have to square root that. All right, so I'm just going to move up on my screen. All right, so square rooting this, second square root, I can just do my answer button, or square root 970, and so it's telling me that that height at a slant is, to the precision of, let's just say 1 decimal space, the question mark, which is the slant height, which is equal to 31.1 centimeters. Okay. All that did was tell us S. Now we got to use all these numbers back up here to compute the final surface area. I know it's pretty problematic. Let me just keep that written off to the side. Now that S equals 31.1 centimeters, I'm going to make a giant erase here because I can. And all my drawings have just gone away. Sometimes I wish the problems would go away just like that too. And now I can zoom back in and go back to the original problem at hand. We're trying to figure out the area totally of this cone. Let's start with the surface area, or rather the area of the circle. So pi r squared. So it's going to be pi, the radius is 10, and the radius is still 10. And so what we're going to get is pi times 10 times 10. And because these dimensions are dimensions with centimeters and centimeters, we're going to have centimeters multiplying each other, giving us a centimeter squared. Now, mentally, I know that pi is roughly 3.14, roughly, and I know that 10 times 10 is 100, and I can use a shortcut of moving some decimal places over, but if you want to put in your calculator, you can. I can say it's approximately 314 centimeters. If you don't believe me, use your calculator. All right, this whole surface of the cone on top is going to be pi times r times s. And we make all that work just to figure out that s. So plus pi, which is pi times 10 times 31.1. Ew, ugly looking 3. That's okay. Now again, these two are dimensional, so it's going to be centimeters times centimeters, centimeters squared. Now my calculator, I'll probably do this one. I can still use the 3.14 times 10 times 31.1. Ooh, that's way bigger on the outside than the bottom. And that should be a typical expected values, where the tops are typically much bigger than the circles themselves. Okay, last stage, we're going to simply take the circle and take the cone top and add them together. So I got 976.54. We're going to add 314. And lo and behold, we have 1290.54. And if we wanted to round, you could put 1291. So the surface area of this sphere is 1290.54. And what am I missing? The centimeters squared. And that should help you out with some of your problems for your practice. I know you got some stacked problems in there. Total surface areas, add up all the areas. It does, remember, with pyramids, what you want to do, just a quick recap. Zoom way back up there on the pyramid. The pyramid is best laid out with this thing called a net diagram that is mentioned on some of your workbook assignments. So drawing out a net means drawing out the little flower of the base and the separate triangles. All right, whoopsie daisy. So that should help you out with your problems on your assignment.